Alrighty, so here are the answers to the power quiz that we did about 4 or 5 classes ago. I'll just say nonsense words for a few minutes, waiting for people to put their attention towards the front. Yes, Josh? It was a clicker one, we did it a while ago. And I think we ended right at the end of the period. I didn't get a chance to go through it. So Megan has asked me to go through it, and I think there's a few others that want to listen. If you don't want to listen, that's fine. Just be quiet so that these people can hear. Okay, so we got 2 physics students, Will and Abel and Ben Pump and Iron. They're in the weightlifting room. Will lifts a 100-pound barbell over his head 10 times in a minute. Ben lifts a 100-pound barbell over his head 10 times in 10 seconds. Which student does the most work? And the correct answer is C, the same amount of work. Why the same? Oh, I even think, look, I have an answer key in here. Look at that. Ben and Will do the same amount of work. They apply the same force to lift the same barbell the same distance over their heads. That's nice having that answer key there. Like that. Does that make sense? Who's listening to me so I know who I'm talking to? Okay, so just about everyone. Okay. Okay, which student delivers the most power, though? Oh. I don't remember which one was faster. Ben? Ben does it in 10 seconds. Oh, Will does it in a minute, right? So yes, B, Ben. He does it faster. He's more powerful. He's been pumping iron. Not even a smile at O'Reilly. Okay, number 3, during a physics lab, Jack and Jill ran up the hill. I don't know why. Could be. Jack is twice as massive as Jill, but Jill ascends the same distance in half the time. Who did the most work?
That's the same.
Ooh, you got to be careful here, right? The same, Josh?
Jack.
Why does Jack do more work? Because he weighs more. Exactly. He's more massive. He has more potential energy at the top, right? Easy, right.
Wait, did you check the answer?
No, I know it's A, Jack. But I'm guessing the next question is, we're doing number 4 next. I'm guessing the next question is who's more powerful? Yeah, and so that one is the same. Right? He weighs more, but he goes slower, right? Exactly. A tired squirrel, a mass of approximately 1 kilogram, does push-ups by applying, have you ever seen a squirrel doing push-ups? By applying a force to elevate its center mass by 5 centimeters in order to do a mere 0.5 joules of work. If the tired squirrel does all this work in 2 seconds, determine its power. So power is work divided by time, right? And the work done is going to be FD over time. And that's going to be weight force, so that's mass times gravity. So really it's mgd over t, I think, right? So that's going to be 1 times 9.8 times, the distance is 0.05 all over. Oh, we already know how much work. I don't need to figure that out. The work is 0.5, right? In 2 seconds, 0.5 divided by 2 is going to be 0.25. 0.25, and that would be watts, right? Measured in watts.
That's 0.25, right? No?
Johnny.
Pay attention. You just said Google Maps.
Am I good there? Toss it. Talk later. When doing chin-ups, a physics student lifts her 42-kilogram body a distance of 0.25 meters in 2 seconds. What is the power to 1 decimal place? So this you'd have to go work divided by time. Oh, we don't have the work there, right? So it's going to be mass. This is going to be 42 is the mass times gravity times the distance 0.25, all divided by the time, 2 seconds. 51.5 is the answer. And that's going to be also watts, right? Now, this is kind of tricky, this one. Your household monthly electric bill is often expressed in kilowatt hours. I don't know why they do that. Like, not kilowatts per hour, kilowatt hours. A kilowatt hour is the amount of energy, so joules of energy, delivered by the flow of 1 kilowatt, which is 1,000 watts, for 1 hour. Use conversion factors to show how many joules of energy you get when you buy 1 kilowatt hour of electricity, right? So a kilowatt hour is 1,000 watts, right, for 1 hour. So that's how many seconds? 60 minutes times 60 seconds. So 60 times 60 is 36. So you get like some big giant number.
Yeah, with the big hat.
Yeah, 360,000, I think, right? I think it's just 1,000. Yeah.
Oh no.
Did you? I'll ask him next time I'm talking about it. An escalator is used to move 20 passengers every minute from the first floor to the second floor. The second floor is 5.2 meters above. The average passenger's mass is 54.9. Determine the power requirement in order to move this number of passengers in this amount of time. Power equals work divided by time. So that's going to be the weight force. So we got 20 people times the mass of 54.9
Use the stapler.
times 9.8. What do you need, Megan? Oh, I'm out of Kleenex. I'm sorry.
Oh my gosh.
I'll have to get some more. 20 times 54.9, that's going to be my weight force, multiplied by the distance, 5.2, all divided by time, which is it every minute? Every minute, divided by 60. And you should get 933.
Oh, we got 32.
Well, probably, yeah, round up.
Round up.
Straight on the weeds, round up. How many questions we got left?
That's it.
That's it? Oh, okay, awesome. Okay.